linear transformation statement. A linear transformation T from V to W has an inverse if and only if T is bijective. So first we are going to prove here necessary part, that is given here. Given T is a mapping from V to W has an inverse, and our claim is that T is function T is bijective, mapping T is bijective. So now given, since T is a mapping from V to W has an inverse, this implies there exists a linear transformation T inverse from W to V such that T of T inverse is equal to IW, identity transformation from W to W, and T inverse of T is equal to IV, identity transformation from V to V. Now what is the identity transformation? Suppose if we define a mapping from T from R square to R square such that T of xy equal to xy, then each element maps to itself. For example, T of 1 2 is equal to 1 2, T of 2 3 is equal to 2 3, and therefore this is called identity transformation. So if the given transformation has an inverse, then T of T inverse is the identity transformation from W to W, and T inverse of T is an identity transformation from V to V. Now to prove that T is bijective, we want to show that T is 1 1. That is, here to prove bijective, we want to show that it is 1 1 and onto, or injective and surjective. So now consider T of U is equal to T of V. Now apply T inverse on both sides, then T inverse Tu is equal to T inverse TV, but T of V. But what is this T inverse Tu? This is nothing but the T inverse of T U equal to T inverse of T V. Okay, so but what is T inverse of T? T inverse of T, from this it is what? Identity transformation from that is IV, and here it is what? IVV. That is IV. What is identity transformation? It maps itself. That is, what is T identity transformation? Here 1 2 maps to 1 2, 2 3 maps to 2 3. Similarly, if it is identity transformation, this IVU maps to U, okay, and this identity transformation maps to what? V. So we start from Tu equal to TV and we get U equal to V. So now since T of U equal to T of V implies U equal to V, and therefore this implies T is injective, or 1 1, injective, or in other words it is what? 1 1. Now next we are going to show that T is surjective, or T is onto. So what is the onto function? When we said this function is onto, when we said this function is surjective, if for any W belongs to W, there exists U bar belongs to V such that T of U is equal to what? W. So let W bar belongs to W. Now since there exists an inverse, function is what? T inverse W is a mapping from V to T inverse mapping is from W to V, this implies T inverse of W bar is equal to what? U bar, where U bar belongs to V. U bar belongs to V. Now consider T of T inverse W. Then this is nothing but T of T inverse W. Okay. Again, sorry. This, as we know that T of T inverse is identity transformation. Say here, T of T inverse is identity transformation. So this is nothing but the IW. So this is equal to what? IW, that is IW of W. So now what is this T of T inverse? This is nothing but the T inverse of W. But what is the value of this IW identity transformation is what? W bar. Okay, so this is what? W bar. Now what is T inverse W? What is the value of T inverse W bar? It is what? U bar. So this is equal to what? U bar, and which is equal to what? W bar. So W bar belongs to W bar. There exists U bar belongs to V such that T of U bar equal to W bar, and therefore now since and therefore for any W bar belongs to W bar, W bar belongs to W, there exists a U bar belongs to V such that T of U bar is equal to W bar, and therefore T is surjective. This mapping is what? Surjective, that is T is onto. This is equal to onto, and therefore now since T is 1 1 and onto, and therefore this implies T is bijective. Now next, in converse part here, converse part we are going to prove here. Now suppose T is a mapping from V to W is bijective. And what is our claim? Your claim is that T has an inverse. Function. Okay, T has an inverse mapping. So now T is a mapping from V to W is a bijective. Now since T is a mapping from V to W is bijective, implies it is 1 1 and onto, that is T is a mapping from, this implies T is surjective. In other words, it is more onto, and therefore for any W bar belongs to W, this implies for any W bar belongs to W, there exists a U bar belongs to V such that T of U bar is equal to W bar. T of U bar equal to W bar, and now since T is injective, injective, this implies therefore this U bar belongs to V is uniquely determined by this, there exists uniquely determined by W bar belongs to W. Why it is uniquely determined? Because T is injective, so that's why this U bar is what? Unique, so that T of U bar is equal to W. Now for this W bar belongs to W, and therefore for W bar belongs to W and U bar belongs to V, define T1 is a mapping from W to V such that T1 of W, say T1 of W is equal to T1 of W is equal to U bar. T1 of W bar is equal to U bar. Now consider T of T1 W bar. So this is equal to T of T1 W bar. But what is T1 of W bar? This is nothing but the T of U bar. But what is T of U bar? T of what is here? Um, T of U bar is equal to what? Here you can check. T of U bar is equal to T of U bar is what? W bar. Since why? T of U bar is what? W bar. So this is equal to W bar, and therefore T of T1 W bar is equal to W bar. This implies T of T1 is equal to identity transformation from W to W. Similarly, consider T1 of T U bar. Then this is equal to T1 of T U bar. But what is T of U bar? T of U bar is what? W bar. Here you can check. T of U bar is what? Sorry, this is nothing but I am highlighting. This is what? T of U bar is W bar. So this is what? T1 of W bar. But what is T1 of W bar? Here you can check again. What is T1 of W bar? T1 of W bar is equal to U bar. So this is equal to U bar, and therefore this T1 of T U bar is equal to U bar, and therefore if the element maps to same U bar for any vector. Okay, for example, here you can check. It is what? 1 2 maps to 1 2, 2 3 maps to 2 3, 4 5 maps to 4 5. Then it is what? Identity transformation. This is what T1 of T is equal to identity transformation IV. Okay, so now since T of T1 is equal to identity transformation IW, and T1 of T is equal to IV, and therefore T1 is an inverse. This is nothing but the definition of inverse. Therefore T1 is inverse function, inverse linear transformation from W to V, and therefore this implies T has an inverse. This is what we want to prove.